It's a new type of supernova that's super rare. I'd like to call it a naked supernova because we're seeing the guts of a star before it explodes. It tells us everything about how supernovas form and also like how we form, you know, the atoms that make us up. This is pretty cool.
We're going to rate this episode MA because we're talking about naked supernovas. The story is coming out of a combination of institutions.
Yeah.
We have Northwestern, Caltech, and the Weizmann Institute.
So studying supernovas is extremely important for understanding not just like how stars live their life, but also like how we get the atoms that make us up. Okay? Because stars like our sun only create atoms up to the element iron. Okay? But you know, the periodic table has a lot of elements after iron.
It's very
Stars are these cosmic crucibles, right? Like in the beginning,
in the
beginning after the Big Bang, there was only really two elements, hydrogen and helium. Right? Fusion, which is the process of taking lighter nuclei and fusing them to make bigger nuclei. The fundamental form that's happening in our sun is hydrogen, 4 hydrogens fusing to make a helium. And then helium can fuse to make carbon, 3 of them. That process requires the energy of the nuclei to be lower than the constituents that made it up. That way, like, it's thermodynamically more favorable to make that.
Makes sense.
Does that make sense?
You lose a little bit of energy when you
Yeah. And you want to, and the universe wants to dissipate heat because of the second law of thermodynamics. And so this process actually dissipates heat, which is fine. Great. The universe is like, you guys do that all you want. Once you get to iron, fusing elements higher than iron means that you need to inject heat. Okay. And that's something that the thermodynamics doesn't let you do, right? Because second law of thermodynamics says that like the energy should go off everywhere, not concentrate into a single spot, right? The entropy should increase, not decrease. But this requires a decrease in entropy. And in order to get anything higher than iron, the energy per nucleon is actually higher, which means that you need a giant energetic event to actually start fusing stuff from iron to make zinc and gold and copper and uranium and all this other stuff.
This is why the explosion matters.
Yes, and this is why the explosion matters. Now, supernova, we've characterized supernova all over the universe, okay? And usually with supernova, you get to see the star as a whole collapsing, okay? This one is pretty crazy because like there were these intermediate stages where the star sort of shed its outer layers. And you got to see the real core of the star, right? And we got to see like the inside. And we got to confirm a lot of these models that we have about stellar evolution.